The book is Semantic Web and Ontology by Dahana Nadini. The World Wide Web is not a static container of information, but it's an ever-expanding ocean of facts. Every year, on an average, 51 million websites get added to the web, and this figure has little chances of getting abandoned in the future. To retrieve the information exactly what we want, Semantic Web has been created. For example, open Google and type the following two words, joy and delight. You will get different sets of results in both the cases, though both the words mean the same. This is because the web can't understand that both the words mean the same. At the most basic level, the web pages are considered as strings of words and processed. Now assume I am submitting the following two queries to any of the current search engines such as Google or Yahoo. Query 1. Domino serves well under heavy load also. Query 2. Domino serves well under high demand also. Query 1 is about a software called as Domino, an IBM server application platform used for enterprise email, messaging, scheduling, and collaborative that is capable of working well under heavy loads as well. Whereas Query 2 is about a pizza outlet that serves well under high demand. When submitted for processing, the search engine could not provide an appropriate result of either of the queries. The reason behind this is that the system is not smart, but Semantic Web provides this smartness. Semantic Web begins with a very complex topic. The best way to understand it is to compare and study with the applications and technologies that we are familiar with. So, let's study the topic of Semantic Web with the help of our favorite search engine, Google. Before moving on to the technique used by Google, let's try to understand some of the basic concept related to it. When the spider, which is a robot on search engine that retrieves information from website based on its text, is reading, it will automatically consider the different word to be the same, or in some cases, the opposite. To avoid it, the semantic web is created. Knowledge will be organized in conceptual spaces according to its meaning. Second, keyword-based search will be replaced by query answering. For example, requested knowledge will be retrieved, extracted, and presented in a human-friendly way. Third, query answering over several documents will be supported. Last one, defining who may view certain parts of information, even parts of document, will be possible. For example, let's say that you wanted to have lunch with your friend, Heidi. Then you might have a series of conversations with Heidi. For instance, consider the following set of the conversations. I have a meeting in my office, so cannot go tomorrow afternoon, but after 3 p.m. I'm free. B. That will do. Let's go to Moldova. A. I'm a vegetarian, so that doesn't work for me. So on. If semantic web technology were used in this transaction, Heidi would have an agent that would have access to all kinds of information about her, including her calendar, any food preferences, and allergies she might have, and restaurant ratings she's given. Your own agent would have access to similar information about you. These two agents will communicate with one another and then automatically suggest something that makes sense for both of you. They could even make the reservation for you. More practically, researchers are using semantic web technologies to enable machines to infer new facts from existing facts and data. That is, semantic web technologies enable computers not only to store and retrieve information, but also to come up with entirely new information on their own.